This video demonstration is case study exercise number 9, differential staining the gram stain. The gram stain is really the most important use stain that is going to be used in a clinical laboratory setting. So our goal is to distinguish between a gram-positive organism and a gram-negative organism. This is going to be performed on, say you have a client that has cerebral spinal fluid removed. They're going to immediately do a gram stain on trying to determine which bacteria it is. So this is why we call it a differential stain. We're differentiating bacteria from one another. So, to recap the difference between gram-positive and gram-negative bacteria, remember the gram-positive bacteria and think P positive, there is a lot of peptidoglycan. And because of that increased peptidoglycan, we're going to end up having gram-positive bacteria appear purple. So remember the 3 Ps, gram-positive, peptidoglycan, purple. The gram-negative bacterium, if you remember, has peptidoglycan, but far less of it. It has that additional outer membrane that's present on the gram-negative bacterium, and hence why when we go through this process, you'll see it doesn't end up being purple. We'll discuss this as we go through the staining technique. So for this procedure, you're going to be wearing your personal protective equipment. You are going to have your heat-fixed slide. We're working with E. coli. The reagents that are used for the gram stain are crystal violet. Going to use iodine, acetone, which is a decolorizer, and safranin. We also need our dropper of water to rinse off the stains as we go through. Because this is a video demonstration, I'm not going to wait the timeline in between each stain as it sits, but you'll see the technique. So first, when we start off with this heat-fixed slide, our bacteria obviously are colorless because no stain has been added. The first reagent that you're going to use is crystal violet. Just like with the simple stain, you only need a drop or two. You don't want the dropper to touch the slide. You drop your 1 or 2 drops and you're going to wait 1 minute. That allows that stain to adhere to the bacterium. This is also considered to be a basic dye, so it's attracted. Sits for 1 minute. After that 1 minute, you can either hold the slide with your clothespin or with your fingers. You'll take your distilled water and you're going to rinse that slide. So hold it at an angle, let your water drop, and you're done. You do not have to have a perfectly, if you look at this, I still have some crystal violet. It does not need to wash off all the way. You don't need to have this beautifully, perfectly clean slide. So this crystal violet now, regardless if you have a gram-positive or gram-negative organism, the bacteria appears purple. The next thing we're going to add, our next reagent, is iodine. You're going to follow the same process. 1 or 2 drops. And that will sit for 1 minute. What the iodine acts like is what's known as a mordant. And a mordant is going to allow that crystal violet that's been placed to directly adhere to the peptidoglycan. This iodine, when added to whether it's gram-positive or gram-negative, the bacterium is going to appear this purple-like color. This sits for 1 minute. You follow the same procedure with holding the clothespin on. But in this case, we're going to add the acetone. And acetone, for you girls, you ladies with your nail polish remover, acetone is going to act the same way as it does on your nails on the bacteria. It's going to decolorize or wash that stain off. Now, I mentioned the iodine acts like a mordant. With the gram-positive bacterium, due to all that peptidoglycan, that crystal violet is going to adhere. But remember, with a gram-negative organism, it has that outer membrane, and that outer membrane has lipids in it. So what's the acetone going to do? It's going to destroy that outer membrane and allow that crystal violet and iodine to wash away. Be careful with the acetone though, because it's so strong. When you add it, you only want to add about 3, 4, 5 drops, and then you need to immediately wash off that acetone. You can say a little sloppy there, I wasn't quite prepared. And then wash that acetone off. If you don't wash it off fast enough, what will happen is you could possibly, with the gram-positive bacteria, wash off the peptidoglycan and destroy that gram-positive bacteria and wash away the crystal violet. So, key note there is that when you add the decolorizer, you have your water available and ready to go to rinse off that slide. You rinse, and now you add what we call the counter stain. The gram-positive bacteria right now should still be purple because that iodine has that crystal violet on the peptidoglycan. The gram-negative organism right now is clear. It's colorless because the acetone washed that color away. So we add this counter stain, so if I have a gram-negative organism, it's clear. I've got to add some color to it so I can see it under the scope. You add your safranin. That's going to sit for 1 minute. After that 1 minute, you rinse with distilled water. Once again, we're not following timing right now. You will then pat this slide dry, just as you did with your simple stain with the bibulous paper. Pat, pat, and then you'll end up going to oil immersion. So with E. coli, it's a gram-negative organism, so under the scope, once we go to oil, we should see gram-negative coccobacillus, so it's like a plump rod. You are going to be responsible for knowing different organisms that we're going to be working with in the class, and whether they're gram-positive or gram-negative.